Over the course of the next week, I have 3 smaller videos for you to watch that are going to explore each of the gas laws as we go through them. We've already covered Boyle's Law and Charles' Law in class, the basics of it, but we need to continue covering it with the math portion. So I'm expecting you to watch the videos, pay attention to the math. We'll do practice problems in class, but I want you to understand what's going on. For the test coming up, you will need to be able to use these formulas. We are going to begin with Boyle's Law. This is our first of 3 in the series here. And conceptually, Boyle's Law just states that it's an indirect relationship between volume and pressure. This is when temperature is kept constant. So what this means is that as pressure increases, volume decreases. You can also say it as pressure decreases, the volume increases. With an indirect relationship, the one variable increases whereas the other variable decreases in each case. Some real-world examples of Boyle's Law is how a shaving cream container works, or anything that's under pressure. A car engine piston moves in and out based on Boyle's Law, and also a spray paint container works because of Boyle's Law. The math behind Boyle's Law is as follows. When given a problem, you're going to look for the first pressure times the first volume equals the second pressure times the second volume. P1 V1 equals P2 V2. If you know this formula, you can plug it in for any of the problems that we have to do and figure out exactly what you need to solve. So if we go ahead and take a look at this example problem here, what I've got going on in the problem is a balloon has an initial volume of 500 milliliters at 105 kilopascals. What will the new volume be at 210 kilopascals be? In this case, our initial volume is this 500 milliliter part here. Okay, so this is V1. And then our initial pressure is the 105, it's the 105 kilopascals. Now on a problem, if you see kilopascals, that's going to be your unit for pressure, and milliliters of liters will be your unit for volume. So that leaves us with this 210 kilopascals being our second pressure. Now knowing this, we can then go ahead and plug this in for our problem. And so for V1 P1 equals V2 P2, I'm going to plug in 500 milliliters times 105 kilopascals, and that's going to be equal to an unknown volume times our final pressure of 210 kilopascals. Now before I even solve this problem, I can look at what I have for pressure at the beginning of this problem and pressure at the end of the problem and have a general idea of whether volume is going to increase or decrease. So we're going from 105 kilopascals to 210 kilopascals. That's an increase in pressure. Now knowing what we know about Boyle's Law, where pressure increases and volume decreases, this means that my final volume has to be smaller than 500 milliliters. If it is not, you have done something wrong in the problem there. So what I'm going to do is I'm going to take that 500 milliliters and times it by 105, and that gives me a value of 52,500, and my units on that's milliliters, kilopascals, and that's going to be equal to 210 kilopascals times an unknown. So when I solve for x now, that means that its final value here is going to be 250 milliliters. And if we go back to what I said before, Our volume should be smaller than our initial starting volume because the pressure is increasing. And we can see from the problem that the pressure is about doubling, so the volume is being cut in about half. We're going to do more of these problems in class. You'll get more practice with it, but I do want you to know how to plug these numbers into the formula V1P1 equals